Alright, so here's a second example of a similar type of graph to the one that we did in class today. And in this graph, we're talking about, start with the zeros of r equals 3 plus 2 cosine theta. Remember that means that's where we want r to be 0, so 0 equals 3 plus 2 cosine theta, so ultimately minus 3 over 2 equals cosine theta. And if we stop for a second and look at that equation, there are no solutions. It's outside of the range of cosine. So there are no solutions, therefore there are no zeros. Our symmetry, because we notice that the graph is a function of cosine theta, our symmetry is over the line theta equals 0. And our max point occurs when theta equals 0, again, because we want cosine to be 1. It could be 0 or 2 pi or anything of the sort. And that's going to occur at 3 plus 2, which is 5, comma 0. Alright, so we can go ahead and put that on the graph. 1, 2, 3, 4. There's 5, comma 0. That's 1 point on my graph. Right? And then I go and I make a table. And you can see I've already started to prepare a table down here. So I go up to pi over 6, and I go, okay, pi over 6 is 3 plus root 3, which is about 4.7. And then pi over 4, which is 3 plus root 2, which is a little bit less than that. And then pi over 3, we get to 4, and these are nice, easy numbers that we can already tell where the points go. And pi over 2, we're at 3. And then at 2 pi over 3, we keep going. Right? We keep going around because we know that we need to see more behavior. We know it's reflective over this axis right here, but we don't really know what happens in the second quadrant. So we keep going and say, okay, 2 pi over 3, we get 2. And at 3 pi over 4, I get 3 minus root 2, which is 1.6. And then I get 1.3, and then I end up at 1. And then I go back in the other direction, and I start to repeat those points, right, that I just had until I get back ultimately to where I started. So I'll go about drawing this graph, and you'll notice that while it's similar to the graph we drew in class, right, it's slightly different. Slightly different than the graph we drew in class. You notice that the dimpled nature, right, it is not quite as dimpled as the graph that we drew in class. It ends up being far less inverted, as if we didn't punch it quite so hard to create the shape. Okay, so that's our example number 1. I'll do a second example on another video.